Right, let's look at a couple more of these average value problems and put the whole problem together. Sometimes we just do part, sometimes we do the whole thing. Meaning, I want to estimate at the beginning what we should get for a result. I want to go through the process of getting it. And then we'll answer an additional question, which is when is the value of the function equal to the average value? So first thing is get a picture, helps us understand what's going on. We got square root of x on the interval 1 to 16. So that's going to be, I'm not going to count precisely here out 16 squares, but square root function, it's going to go through 1, 1, 2, 2, blah, 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 9, 3, and then somewhere around here it's going to get to 16, comma 4. So we're looking at half of a sideways parabola, looks roughly like that. And we're looking for the rectangle that will have the same area under it as this curve has. And I'm going to guesstimate somewhere around there. Remember, look for the overestimate and the underestimate to cancel each other out. You want to do this in your calculator or in Desmos. In Desmos, it works beautifully. Gives you a really nice picture. But I'm guessing somewhere between 2 and 3 is going to be our answer. Well, let's find it. We do the integral over the interval 1 to 16 of the square root of x dx. That's going to be x to the 3/2 power divided by 3/2 or times 2/3 from 1 to 16. That's going to be 2/3. 16 square root is 4 cubed is 64 minus 1 to the 3/2 power is just 1. So you end up with 63 in there, which is 3 times 21. So multiply that by 2. I'm sorry. We can cancel out the 3. That'll leave us with 2 times 21, which is 42, the answer to the question of life, the universe, and everything. That is the area under this curve. If we want the height of this, our average value for the function, we then need to divide it by 15, which is the length of the curve, right, from 1 to 16. And 42 over 15 is our average value. Those are both divisible by 3. I believe that's 14 times 3 and 5 times 3. So there is our average value. Now, if we averaged a speed, right, if we were taking a trip and this was our velocity, and our average speed was 14 over 5, that means that at some point on this journey, our speed had to have been exactly 14 over 5. And the other thing that we're talking about, or this visually what we're talking about, is if this curve is going from somewhere lower than our line to somewhere higher than our line, it's going to have to cross it somewhere. So at that point, our speedometer reading was 14 over 5. How do we find that point? It's simple. It's when was our original function equal to our average value. Okay, that's the third part of the problem is we found the average value. Let's find when our function was equal to that average value. Square both sides. We get 196 over 25. 196 over 25 is just about 8, just a little bit less than 8. And I got a pretty crappy drawing here, but 1, 2, 3, 4, 5, 6. I got just a little bit less than 7, which for a crappy drawing is actually pretty close. Use Desmos, and you'll be able to just poke that point right there, and it will tell you it's 196 over 25 in decimal form. Let's do one more. 4x minus x squared over the interval 0 to 4. We've looked at this function a couple times in the last few lectures. It's one of my go-to functions. It has an x-intercept of 0 and 4, and a vertex of 4, 2. 2, 4. It's an upside down parabola. Technically not upside down, it's just oriented downward. And if I were going to guess what the average value was here, I'm looking for where the overestimates and the underestimates cancel each other out. And I would say that might be a little low. So that's at 2, 2.5. I'm going to go for a little bit higher than that, and I'm going to say it's a little bit less than 3. All right, let's find exactly where it is. let's find our integral from 0 to 4 of 4x minus x squared dx. Sorry, I had the dx in the problem. That didn't belong there. And at this time, let's go ahead and divide by the length of the interval at the very beginning. The length of the interval is 4, so I'm going to put that 1/4 out there. To evaluate the integral, 1/4, antiderivative of 4x we know is 2x squared. The antiderivative of x squared is x cubed over 2 from 0 to 4. Good news is we don't have to plug the 4 in. I'm sorry, the 0, just the 4. So we'll get 1/4. 4 squared is 16 times 2 is 32. 4 cubed is 64 divided by 3, not divided by 2. So that's minus 64 divided by 3. 32 minus 64 over 3 is, let's see, that'd be 96 minus 64 over 3 is 32 over 3. So we have 1/4 times 32 over 3. Well, 1/4 of 32 is 8. So we have 8/3 is equal to our average value. That's our average value is 8/3, which is just a little bit under 3. It's 2 2/3. So that matches with my guesstimate. And the last part of the problem, which I may or may not do here, is try to figure out when is 4x minus x squared equal to 8/3. And I don't think I'm going to bother doing that. We can certainly do it. We can multiply through by 3 and have 3x squared minus that, and then plus 8 equals 0. And we can try solving that, but I am just plain not interested in bothering with that at the moment. So this one, I would say, use your calculator to find that intersection point. There would be 2 of them, of course, or use Desmos, and Desmos is easier because you can just poke it. Just like I'm going to poke this stop button